Hey, thank you everyone for joining us tonight. It is September 2nd, and we are excited to have everybody here for our presentation tonight with Mr. Thomas Rayner, who's going to be talking about supercharging your Git repos with Git hooks. And we're going to turn it over to Mr. Rayner.
All right, thanks everyone for joining. We are going to talk about Git hooks tonight as promised. Real quick, just to provide some credibility, I'm Thomas Rayner. I'm a certified, I have a CISSP cert. I'm a security engineer at Microsoft. I've got a blog you can check out, thomasrayner.ca. The PowerShell Discord and Slack is terrific. It's bridged, so you can join whichever one you prefer. And you'll talk to the same people. If you're looking for any type of PowerShell help, or even just to contribute or get more in touch with the PowerShell community, can't recommend it highly enough. So that's enough about me. Let's talk about Git hooks. And let's do a little level setting first, because like I know Git and source control in general can be kind of a weird one for operations people and PowerShell people to get their heads around in the first place. Like I did my, I think it was my first or second presentation for this user group, was just like the 6 commands you need to know to survive. And this is beyond survival. This is moving into the thriving phase of working with Git. So first, like, okay, sure. What is a Git hook? Maybe that's a good question to start with. Git hooks are just scripts that run whenever a certain event happens in a Git repo. So like, for example, the one I have on the screen here is when you type git commit, a script runs and does something. So there's lots of events in Git. There's commits, there's pushing, there's pulling, there's merging, there's rebasing. There's different periods within each of these events. And you can create hooks that trigger these scripts for all of these different events within Git. What do? Like, they do anything you want. It's an arbitrary script. You can write them in PowerShell, you can write them in Bash, you can write them in Python, you can write them in anything you want. You'll see, because Git is made by Linus Torvalds, who is also responsible for a popular operating system platform called Linux. You may have heard of it. PowerShell runs there too, but it's kind of a recent development. So a lot of the Git hook scripting looks a little Linuxy, but don't worry, you're going to be just fine. And like, okay, well, why would I want to do this? Like, that's probably a good question, because you can customize the behavior of your Git client, and you can use it to customize the behavior of the people participating in your repository that you control. So if you've got a bunch of people that you work with and you're just getting them on source control and you wish they would do something a little differently with their Git hygiene or their practices, you can help put the bumpers down on the pool gutters to help them avoid throwing a gutter ball and kind of guide them through the right steps. If a Git hook exits in a non-zero, like if it throws anything other than a successful exit, it can abort the operation that's in place. And we'll talk about more about that. But you can stop Git from doing things if some of these hooks don't complete successfully, which is kind of nice, because a lot of the time you do something, you go, oh man, this is going to be such a pain to undo this. Well, what if it just caught itself and stopped itself before that ever happened? So what else can we do? You can encourage a commit policy, alter the environment, run tests, integrate with your CI/CD system, send emails, do literally anything that you can write a script for. You can make it part of your Git hooks. All right, now I'm sure I've sold you. You're all a champion of the bit. And you go, I need to get my hands dirty. How do you use them? Well, let's keep going.
So is this more like the idea that we're automating the Git process itself? Is that what this is all about?
Not necessarily. You're adding customization to the Git process, and you're adding your own scripting and utility around the process itself.
All right, cool.
It'll become a little more clear as we go through it, like exactly what the utility here is. So we should first talk about types of hooks, right? The first is local hooks. These only affect the repo that they live in. And by repo, I mean like the local copy of the repo. So that's the copy that's downloaded to your computer. That's the copy that your peer downloaded to their computer. Those in this context are different repos. It's the same like Git repository, it's the same project, but in this case, these hooks live in your specific instance of that repository. And therefore, developers, and if you write code, you're a developer, so to say, can edit their own hooks because they just run locally and they're not cloned along with the repository. So that may initially seem a little bit limiting. And it kind of is, but you'll see why that sort of works that way as we go forward. But these are files that are on your local copy of the Git repository that you're using to interact with your Git process. There's server-side hooks as well, which are not widely supported. GitHub does not support these. Azure DevOps does not support these. I think GitLab supports them. I don't know about like Bitbucket and others, but most popular is obviously GitHub, and in this audience, probably Azure DevOps. They don't support server-side hooks. They do support automatic builds. GitHub has actions, Azure pipelines. This all runs, can be set to run automatically when you push to a branch or something, which is usually what you would want to do with a server-side hook. But we're not going to talk about them much because they're not widely supported, and there's other ways to achieve the goals you would normally think to achieve with that. But they would run on a remote, like your GitHub remote or your Azure DevOps remote or something. In this presentation and going forwards from here, we're only talking about local hooks, and that's the stuff that runs on your workstation when you're interacting with Git, and you'll see some cool things we can do with that as we go on. And so this might have jumped out to you. They're not cloned along with the repo. So when you go git clone and you put in the URL and it pulls the repo down, your hooks aren't there. Well, why not? Let's talk about installing a hook, right? Like, how do I set one up? What do I configure? What do I have to do? I got to set this up for like every repository, and everyone who downloads my repository is going to have to set this up. Don't worry, it's not that bad. So every Git repository has a .git folder, right? And that is per repository. That every time you do a git clone, you have a .git folder that doesn't get pushed up to your remote. It doesn't live anywhere else other than on your local copy of that repository, because it's tracking a bunch of metadata. That's where kind of all the inner workings for Git live. And your inner workings and the branches you created locally don't need to go anywhere other than your workstation. Inside of the .git folder is a hooks folder, and that's where all of your Git hooks live. Easy to remember, right? Where do my Git hooks live? They live in the Git hooks folder. And all you'd have to do to install one is copy in your script into that folder. That's it. That's all. Seriously, that's all. There's a bit more. The files have to have a specific name so that so Git knows like what action your hook is tied to, but that's the installation process. So they're very conveniently distributed.
So you're saying in that same fashion, I know you can probably get to it, but you can simply just copy that file around, that folder around, and you're effectively moving it from repo to repo.
Exactly. So this is a peek inside a hooks folder. This is what's in there by default. This is just my demo repository, my catfax repo. And you notice there's a bunch of different files, and they all end in .sample. And that's because they're literally samples. When you want to have a Git hook that corresponds to one of these actions, you overwrite it and remove the .sample extension from it. And then whenever Git detects that you're committing that action, it will trigger your hook. And you see they have lengths, right? Like some are longer and some are shorter, but each of them has content in there that you can use as a crutch and as an aid to kind of learn about the specific hooks. But these are the different events that you can use. And this is kind of an easy way to remember and a reference that you can refer to. Let's look at like the anatomy of a hook. Let's look at some code, right? If I do a get content on this is the pre-merged commit sample. right? So there's an event called pre-merge commit, and we're going to talk about what the different events are so you can kind of get your head around it. But this is the content. Everything below this is what is in that file. This, the red part that just shook, if you're not a Linux person, might look weird. You go, oh, it's commented out. That doesn't run. In Linux, that's called a shebang. And in addition to being fun to say, it tells Linux what kind of shell or environment your script is going to run in. And so this indicates that it's a bash script. You could see a reference to Python here. You could see a reference to other shells here. But the default content that's in here is just a bash thing. So that's what that is. This part, the big part in the middle, is a description of when the hook is called and a description of the sample code that's below. And this also lists what the different arguments that get passed to your hook are. Sometimes when Git calls one of the hooks, it'll pass arguments to that hook. So, and we'll talk about those specifically later. This one, it says, doesn't have any arguments. And it describes how to enable this hook. It describes when this hook gets called and has all that other wonderful information. Great to have that on hand. And then this part below, this is the bash script that runs. This is the code that is executing when this hook is installed and gets triggered. So that's everything that's in this one. I picked this one because it's short and it fits on the screen. You may have seen in the previous slide, I'm sure you all memorized the file lengths. This was a pretty short one. They have much longer ones that have longer descriptions, longer examples of how the code works. Usually when they have arguments that get passed, it shows you an example of working with those arguments too. But I think they're all bash, which isn't necessarily how a PowerShell user group audience is going to want to use them. So my demos are going to show you how they work in PowerShell. But quickly, this is the bulk of the slides, but we're not going to spend a ton of time going through them. I'm going to go through what a lot of the different events are. Not all of them, but the most useful ones. So you get a good idea of some of you. It might spark the creative juices. You might get a bit of an idea of when you can start using some of these before I show you how a demo I've got. So the pre-commit hook, when you type git commit, this runs before Git asks you for a commit message, before a commit is actually created. And this hook is triggered and executed, and the script within that hook runs. It doesn't take any, or it doesn't pass any arguments to your hook. And you might use this for like inspecting what's about to get committed. You might run this when you're gonna automate some tests. Like, hey, wouldn't it be great, like before you commit, make sure you didn't break any of your tests? Well, that's handy because who wants to commit broken code? This way, if you make a Git hook that executes pre-commit before the commit is generated, runs your tests. If your tests fail, then it can abort and be like, "Whoa, this didn't work. I'm gonna stop you from creating that commit." Now you don't have to revert it. Now you don't have to do anything. It's just all good.
So, question in here, now you got me thinking the idea of just like all the different things pre-commit can do. So you could even like the idea that you could run anything across the environment. You're running effectively any script. And so, hey, you want to make sure that you don't commit credentials to your code. And so right here, go look for credentials, objects, and the fault, throw an error, throw some stopper. So then there's some workflow here where you can stop a commit, and you'll get to it, right? Something like that.
Yeah, absolutely. But like you said, like I mentioned, you can run any PowerShell code you want, Python code, Bash code, any code you want to run can be triggered when this event occurs. And if that code exits non-zero, like if you do an exit 1 somewhere in that script, then it's going to stop you from creating that commit. So exactly like you said, like, hey, I'm inspecting what's about to be committed. Are there credentials in there? Well, then maybe my credential scanned through an error and exited in an error state. There you go. There's a question in the chat. Is it safe to say these only run when using the Git CLI and not GUI tools? These should run with your GUI tools, but I don't want to promise anything because a lot of the GUI tools behave in ways that you wouldn't necessarily think they would if you're familiar with the CLI. So a some use commands differently and obscure flags to change the behavior of Git in a way that you wouldn't necessarily expect if you were just kind of living your life in the CLI. I'd recommend experimenting with that if you were more keen for that. But so this is kind of the format that the next few slides go through. When it's going to run, what the arguments are, and kind of what they're good for. We're going to go through the next ones a little quicker here. PREPARE-COMMIT-MSG. This is just, again, this is the complete file name. You make a file called PREPARE-COMMIT-MSG, and you put that in your Git Hooks folder, and then it'll run whatever that code is. And it runs that code, in this case, again, when you run git commit, this runs in the same command that the last one did, but it runs after that last hook. It runs after the pre-commit hook to help populate the commit message. So they're very similar, but they run at a slightly different time. And you can tell because there's arguments that get passed to this one. The last one didn't pass any arguments to the script you're running. But when you run this one, it's going to pass arguments to your hook. And you don't have to use them, but you can. It's going to pass. And so again, in Linux, everything is a file. Even the temporary data surrounding your commit is a file. When you create a commit, it creates a temporary file that includes the message and includes some other stuff. And when you do, and it runs this script, that temporary file is created, but your commit hasn't been created yet. So you get the name of the file that contains the message, like the commit message. When you go like git commit-m and you put a message in there, that's stored in a temporary file. And the first argument you get is the path to that temporary file. And it also gives you what kind of commit it is. It gives you the SHA-1 hash of the commit, if that's relevant, if there is a commit there. So this can be good for manipulating the commit message. This is going to be one of the demos that I show you, if I recall correctly, because you can use it to enforce conformity to message standards. If you want all your commits, like if you have a branch that starts with like issue dash and then a number, and you want all your commits to begin with that issue number, you can write a script that detects the name of the branch you're on. And then if you're on an issue branch, it finds that number and it puts the number as a prefix if it's not there already. And you can build that in. And so if you're somebody who's forgetful or you've got junior admins that never remember to put their issue number in their commit message, then here's a way that you can kind of help them and make that a little bit easier for them to work with. The commit dash message hook also runs when you run git commit, and it runs after you enter a commit message. The hooks assume positional arguments. Yeah, they're in through standard input. I'll show you an example of how the arguments come in and how I like to deal with them. Sorry, just a question there. This also gets a path to the temp file name that contains the message. And so this runs after that message has been put into that file. The one we just looked at is just where the file is. This one shows you, again, it's the same path. You'll see. This is really good for editing the commit message. So you can use the first one to like reject a bad commit message or just put one in the first place. You can use this one to inspect and edit the commit message. Post commit, again, it's just a file named post-commit in that Git Hooks folder that's executable. Runs when you run git commit. But this one doesn't actually affect the outcome of the commit operation. This is just something that runs after you create a commit. So the commit's already created. You can't abort the process of creating a commit with this one, but you can, it takes no arguments, you can email your boss every time you make a commit. Who wouldn't want to do that? Hey, I successfully made a commit. Don't you want to tell everyone? Don't you want to post in Teams about it? Don't you want to tweet about it? You could automate that process. Hey, I just made a new commit. Everyone needs to know. Maybe not. But you can use it to integrate with your CI solutions. Again, you can, maybe this is where you want to run your tests. Maybe you want those broken commits to get created, but you want to run your tests so the person interacting with your code doesn't push them if they're not passing your tests. But you want the commit so they can locally scroll through their history. Just another option. Post checkout is one that I think is a little underrated. This runs when you run git checkout. So you can be checking out a new branch, you could be checking out an existing branch, you could be checking out a file to change the modifications you've made to it, but it runs anytime you successfully check out a reference. It passes what the previous head was or the new head was, and then a 0 or a 1 depending if it was a file or a branch. And so basically the arguments that are passed here just tell you where you were and what you moved to because you checked out a new reference, right? Python people like this a lot. I know it's a PowerShell user group, but Python generates lots of temp files and stuff depending on the modules you're working with. And you can use this to just anything you want to alter your working directory when you check out a new branch. Maybe you have like a dev branch, and when you check out the dev branch, you want a file to be named differently, or you want the contents of a file to be different. You can do that with this. You can even have it where you're changing Git settings, like you're running the git config command to change different settings depending on what branch you have checked out. Again, stuff you would probably just do manually, stuff that might be a little bit niche, but it's a really powerful option to be able to run a script every time you run git checkout. PRE-REBASE, so this runs when you run git rebase, pretty self-explanatory in the name. But the big deal is it runs before anything gets changed. Rebasing is super powerful in Git, and it allows you to rewrite history. Especially if you have permissions to push rebased history to a remote, you can go delete stuff from previous. You can delete previous commits. You can change commit messages. You can change a lot of different stuff with rebasing. When you run it, it passes arguments, which is the upstream branch that the series is forked from, and then the branch that's being rebased. So what's the name of the branch that you're rebasing, and what branch are you trying to fork into? Pretty standard references, because that's what rebasing is. It's moving commits from one place to another, or reworking the one that you're working with yourself. Could be good to make sure you're not about to screw everything up. Always nice. But like a more tangible example, you want to make sure that the topic branch hasn't already been merged, or the one that's being merged hasn't already been merged into the next branch. Again, it's kind of into the weeds of Git if you're not that familiar and comfortable with it, but it's really helpful and useful, and it's another good time to maybe run a, hey, are you sure about this type of script? Pre-merge commit. This runs when you run git merge. So if you're going to do a merge locally to like merge one branch to another, this will run as the merge is being carried out, but before the commit is actually being put into that log. And so you can use this to abort a merge. So there's a whole bunch of different things you would want to do. This works a whole lot like the pre-commit hook, right? Because this runs before that commit actually gets created. An important note about this one, if you do --no-verify, then you skip this hook. You go, well, then what good is it? Well, Git hooks are not a security boundary because the dev has full control over them. You can use them to interact with security tools. You can use them to interact with your different systems and your CI systems and stuff, but the dev has control over them just like they're any other file that's on the file system. So they can skip this verification. Any of the other ones, they can just go delete the hook. It exists on their local file system. So they're not security boundaries. So, but what you can do is use them to interact with security systems so that maybe you hash all the contents of your Git repository, you push that hash somewhere. And when the stuff lands in your, you do the hash again, make sure it wasn't messed with in transit. And if they didn't run that hook, you're not gonna have that hash. You get the idea? Like, you have to get a little creative with how you implement these because on their own, they're not security. They're dev dependent. This one doesn't take any arguments. Pre-merge commit when you're running git merge doesn't pass any arguments to your hook. And like I said, it's kind of the same as pre-commit. You can use this to run tests. Hey, when you're merging, hey, let's do the merge and then let's run our tests. And if all our tests fail, let's hit the brakes. I don't want to merge anymore because all my stuff's broken. This can save you some headaches for that. rather than trying to go reset your branch and undo a commit, undo a merge. Maybe you're merging like 40 different commits and they're all in between you get the idea. It can be a little bit of a pain. Good to protect yourself if and when you can. Post merge runs. I heard Mike light up, and I was like, not again.
Now I got a question for you, and maybe we could save this for later. But I'm curious about the idea of running tests when committing. If a person was running things like pester tests on their own, what kind of tests are you running on a repository that would be different than individual tests that someone would run via pester or something like that?
Most of the time, it's probably the same tests. It's to kind of, in my mind, as I'm kind of saying that, is to protect against the admin or the dev, I should say, the person who goes in and manipulates the code and then does a commit, does a push, never ran their tests. And then it's up for code review, and the reviewer doesn't run the tests either, but they assume that the tests ran, and maybe your CI is not set up, maybe it doesn't run on the pull request. Like, this is just to protect you from the person not running the tests locally, or you could have maybe you have a full suite of tests that runs when you're committing, and just a few tests that you run here and there as you're kind of doing the development thing. It's kind of up to you. I have like for PowerShell specifically, maybe you have just a boilerplate pester test that checks for the presence of comment-based help, and you want that to run every time you make a commit to make sure that you didn't screw up your comment-based help, how it gets parsed, and the fact that you have it and everything like that. But maybe that's not part of the functional tests that you run as a developer writing the code, right? It's kind of all up to you.
So effectively, those tests are out of band, and so it's not. So if you're building a module with tests in it, so then you'd want those tests inside the module. But if you want, these other tests that are effectively out of band, these are functional tests that keep the module itself operational, then that is where that test would go, because it's effectively out of band, right?
You can do both. You can have it run the tests that make sure your module's functionality is performing correctly. You can, like, the same tests that just confirm that the thing works the way you want it to. You could run those tests too. You could run the ones that are stored with the module. You could run different ones. You could run whatever tests you like.
Yeah, I kind of think with the example you said is like, do you have comment-based help? It's kind of weird to actually put that in the module that you release to somebody else. It's like, oh, here's a test to see, that not that it's weird, but it's just like, well, that's not to the function. It's like a meta test than a functional test.
Yeah, for one specifically like that, then yeah, maybe you would want to store that elsewhere. But it doesn't matter where they're stored. You can run literally any arbitrary code that you want to, because it'll just run any code in that hook. So if you want to run stuff from a different repo, if you want to run an integration test that tests how it works with a different module on your system, you can do that too. It's really all up to you. It's a blank canvas. The post merge Git hook runs. It runs when you do a Git pull, but it's actually invoked by Git merge, and it doesn't impact the outcome of that merge. It passes a flag specifying whether or not it's a squash merge, and it could be good for manipulating metadata. Use it with a pre-commit hook to kind of save and restore metadata. This one I don't have a ton of great examples for, because you kind of have to get into the weeds of Git a little bit before you're finding a lot of use cases for this. But I just want you to know that this one's out there, so that if you're thinking, oh man, every time I do a Git pull to retrieve more updates and merge them into my branch, I wish I could also. Now you know that this hook exists, and now you know you can do that. Pre-push. This one is kind of underrated. It happens when you run git push, and it can prevent you from pushing to a remote. A lot of the docs out there are like, oh, well, yeah, whatever, this one pre-push. They want you to, the commit ones are the most popular. I think this one's great, because you can still create all your commits, but before you push, maybe you do or maybe you don't want to prevent that push from actually reaching your remote. Passes the name of the remote and the location of the remote. So like when you run git push origin main, the hook receives that reference, the name of the remote, and then that number, that 67890, is the hash of that commit. It's the commit ID. And then it also get like this is all in a string. These are space separated standard input arguments that your hook receives. So you can check out those references. You can do different things. You can manipulate them in any way that you want. But that's what comes into your remote, or that's what comes into your hook when you run this. This can be good for aborting a push, interacting with a remote system. So again, it's another time you could run your tests and keep it from going. You could have this checking to make sure that the username of the person running it has an @yourcompany.com domain attached to it. You want to make, because if you're like me, I've got repos for work, I've got repos for personal, I've got repos for community projects. Some of them live on GitHub, some of them live in Azure DevOps, some of them live in a different Azure DevOps, and I've got my config set up so that my usernames and my display names are different based on which organization I'm pushing to, whether it's GitHub, whether it's a different Azure DevOps. And you can have these run and check. What was your username when you're pushing? Was it the right one? Was there a match? You can, again, anything you want to do, you can prevent that push from happening so you don't have to go rewrite history with a rebase or whatever. And they can be really handy. I'm just going to catch up on the comments. Yeah, the hook will also, yeah, you can have hooks validate ticket IDs, validate formatting and naming. That's great. Yeah, you can run, I like running PS script analyzer in different hooks to make sure that I'm not pushing stuff that'll kind of screw with that. Interested in the pre-push to validate the right username and email. Yeah, and you'll get it. I don't think I have a pre-push one here, but you'll kind of see how that works in the demo. Speaking of which, you can see the orange reflection on my face from this big screen here. It's demo time. We're going to get our hooks in the repo, and I'm going to show you how some of this actually works here. First things first, I'm going to go git clone. I've got this catfax repo. Catfax. I'm going to open that in Visual Studio Code. And I hope that's big enough. You can see I have a few files here, and I'm just kind of killing a little bit of time while my extensions load up. I've got a license, valuable. I have the most interesting script anyone has ever written. It is my favorite in the world. It reaches out to the catfax API and retrieves a cat fact. I wish this would go away forever. I think I need to update the version of the PowerShell extension. I've also got my hooks demo folder, Stevie. And inside my hook demo folder is where you might imagine I have a bunch of demo hooks. Where would you add a hook to try to prevent a password being checked in? We can talk about that in a minute, but I'll show you kind of how this demo works first. You can see if I do dash git hooks, this looks a lot like that screenshot I showed you earlier, where these are all .samples. I don't have any hooks in here yet. My git behavior is normal, or at least as normal as git ever gets. Kind of funny. All of these hooks are in the hook demo folder, but they're not in my git hooks folder, so none of them are running. What I want to do to make that happen is I'm going to copy. I love the PS readline autocomplete stuff. I'm going to get rid of this verbose. I'm going to copy everything from that hook demo folder into my git hooks folder, and I'm going to exclude the PS1s. So I'm going to put this commit message file, this post checkout file, and this PRE-REBASE file into my git hooks. And now if I get the directory listing, all those samples are still there, but now I have my commit message, I have my post checkout hook, and I have my PRE-REBASE hook. And so if you remember when those run, I'm just going to show you all this code first, and then I'll go through them and execute them. Let's just start here. The commit message hook, you remember this runs when I run git commit. I have a shebang at the top, which is just rendered as a comment here. And then the code that this hook executes is I'm executing PowerShell, no profile, and the command I'm running, you have to escape the backslashes. I'm going to run this assert commit message, which is in my hook demo folder. And you'll see this takes a parameter called temp file, and this is how you use the positional arguments in a bash script. Like $1 is the first argument that gets passed, and you'll recall this was the name of the temporary file that gets created when you're creating a commit message. Are the hooks available in a Windows environment? Yes, I'm running on Windows 10.
So you're running on Windows 10 there, but you're calling actually, PowerShell, Windows version 7. So you could go, at this point you'd call like PowerShell.exe and then the whole thing, right? You wouldn't just put raw PowerShell code there.
Yeah, you can put PowerShell.exe in there. I like doing it this way because, again, remember who the person who made Git is. Linus Torvalds made Linux, and this is sort of, in my opinion, the cleaner way of doing it because you don't have to change too much with the command line arguments and the positional parameters and stuff. There were other arguments passed here, but I just need the first one because I passed the path to that temporary file into this assert commit message. And so all this does is calls my PowerShell script. This doesn't have any syntax highlighting that I really enjoy because it doesn't have a file extension. Like when you're working in VS Code, it figures out what type of file you're working with by the extension of that file. And these don't have extensions. So if you start writing PowerShell code, you're not going to get the syntax highlighting and you're not going to get a bunch of the nice stuff that the PowerShell extension gives you. So I like doing them this way, and I recommend you do them this way. You don't have to do them this way though, because I feel like this keeps it simple, and then I can come in and check out my script. This is the script that it gets called. It takes a parameter of that temp file, and then I'm running. I'm getting the content of that temporary file. I'm selecting the first line from it because that's my commit message, and what am I doing here? I'm checking to see, did you come to the regular expressions talk I did like a year ago? I'm checking to see if it starts with this string. If the start of the string is cat-check in my commit message. And if it isn't, I failed the check and it exits 1. And if I don't enter this if block, then I'll exit 0, which is a success code. Can change encoding. Yeah, you can get a little bit creative with some of the other ways, but I really get skeezed out messing with encoding when it comes to Git stuff. The post checkout, you remember this runs after you go git checkout. Again, this one looks a lot like the other one where I've got the shebang and then I'm just telling it to don't load a profile. All I'm doing is running this. You can skip this if maybe your profile is important for these Git hooks. But all I wanted to do is run this reset working directory thing here. And that runs this script. Reset working directory. I remove all the text files from the main directory. This one is this one's particularly contrived, but I kind of like seeing it work. And then I've got a PRE-REBASE. This runs every time you do git rebase. And all it does is run my confirm rebase script. This one's a little bit more fun. This runs, we can step through this in a little more detail, but all of this will get how far ahead and behind my branches from the upstream branch. And if I'm more than 2 commits ahead or behind, I'm rejecting my attempt to rebase. So I'll demo this as we go here. But those are my hooks. I've got a commit message, I've got a post checkout, and I've got a pre-rebase. So if I do if I run this, I do it, let's even check the content. I hit that API, I ran that script, and I put the output into this test.txt file, and I found out cats don't think. Like, don't think that they're little people. They think we're big cats. This influences their behavior in many ways. I bet it does. Can you see why this is just the best API in the world? Like, come on. Like, don't you want to learn about cats? But now I've got one of these text files in here, and I'm not tracking it in Git. So it's not really a part of my repo. If I go git checkout demo branch, I should have put a message in there that talked about deleting files, but my file's gone. And if I go git checkout master again, my file doesn't come back because like it's not like it was on one branch but not the other. That reset working directory script ran and got rid of that. Now I'm going to go check out my demo branch again.
So question there is there's kind of a discussion in chat, like the idea of that, hey, some more cross-plat thing kind of thing. If you'd have some idea or some suggestions with doing some of the scripting for, or the code, the hooks for Linux versions versus the Windows version, because the EXEs are different, the paths are different, the scripting would be different, recommendations there?
Yeah, honestly, I don't cater to a ton of cross-platform stuff in my daily life. You might recall from that bio slide that I work at Microsoft, and you can imagine most of my peers use Windows machines. But so I'm not exactly an authority on the matter, but I know you can script around that, especially in the later versions of PowerShell. You can, like there's which is Linux global variable, or not global, built-in variable. And so if you know that you're running, like if you're running cross-platform, you know you're running in a version of Linux that has this. And you can kind of work that way. You can do the same kind of detections with the bash scripts in your Git hook. And then actually David just had a great suggestion in the chat. You can switch your shebang just to be PowerShell. That might have weird consequences in Windows. It's a little subjective and different depending on how you set up your repos and how you set up your workstations. So I don't have a silver bullet for that, but there's a lot of different stuff that you can do. And probably what I would do is you like run it in bash and then leave the shebang as bash and then detect your platform and then run a different command depending on what your platform was.
Thanks.
There's a lot of different ways to do it. Like that's not the only way. That might not even be the best way, but it's probably what I'd do first. Okay, so I showed you when I check out a branch, it deleted all the text files that I had in my in the root of my repository. Pretty cool, right? One of them just worked. Now I'm going to go git commit allow empty. That makes it so that I don't actually need to have something in my commit. Like I don't need to add a file or make any changes. I can just make an empty commit. And my message -m to include a message is going to be something very descriptive, very helpful. And I always forget to do this. I don't have a global config with this, and so it's complaining that it doesn't know my username and my display name. So it completely aborted this. That wasn't a Git hook. That was just Git. It's saying, hey, use global, and I used local. It didn't matter. It didn't know who I was. Now, let's try that again. Git commit, allow empty, so that I don't actually have to be making a change. If you omit that, like if I don't put that in, oops. I'm gonna go, there's nothing to commit. And I'm gonna go, well, that doesn't really serve my demo, does it? So you have to do an allow empty here. And it's going to tell me that I failed the check. Well, that is about as terse and unhelpful as you might expect Git to be, but that wasn't standard Git behavior, right? If you recall, that was the very succinct and educational error message that I write out when the commit message doesn't start with that string. If I try that again, go at the start there, cat, what was it? Cat check? Yeah, cat check. Now I created a commit, and my prompt is helpfully telling me that I'm ahead by 1 now. If I do a git log, you can see my head of my local demo branch is ahead of where the origin demo branch is by this commit that I just created at, you can see this is local time for me at just before 6:30. So that is that Git hook in action. So again, like this doesn't have to be such a simple file. This could be checking all types of different Git stuff. This could be checking all types of different stuff to do with your system. This could be running tests. This can be any code you want, any arbitrary PowerShell. And so now what I'm going to do is I'm going to create 10 more empty commits. And you're going to go, wow, that's some powerful coding you're doing. That's some really good work. Stevie asks, how can you get a cat effect every time he makes a commit? Make it hit this API every time you do a commit. You can make that your code. I'm also going to quickly check out master, and I'm going to just put an empty commit in there. Demo branch. And now, like I'm ahead by 11 commits here, right? My demo branch is ahead of the remote by 11 commits. And if I go git rebase master, now it's going to tell me your branch is too far out of date to rebase. And then it tells me how many commits I'm ahead or behind. Remember, like again, that's not Git action. That's my script working here. So here's why it's not a security boundary, right? Like if I'm a developer, I know everything. Okay, I'm gonna just change that, and then I'm gonna come back in here, and I'm just gonna do that again. Now I have on stage changes. Git add. Now I failed the check. Now I'm gonna go git rebase master, right? And last time I did this, it told me I was too far ahead. And so it stopped me from rebasing. Now I went and I just changed that because I can, because it lives for my local repo. And I successfully rebased. Now I'm ahead by 14 and behind by 1 because I had that commit on master. You get the idea, right? I just circumvented that. This wasn't a security control. I'm not running this as admin. I didn't need special permission. It doesn't matter what permissions I have to the upstream repo. I can just edit these. So these are here to help developers. These are here to help people writing code. They're not here to protect you from threats, right? You just saw how I circumvented this control that I have in place here. It doesn't protect you from someone who knows that they're consciously editing these files. I could have not copied these hooks into my Git hooks folder, and then they never would have run at all. But they're here to help. They're here as a productivity tool, and that's how you should think of them. Catching up on stuff. Do the Git holders, do the Git hooks become part of the Git branch, or do you have to create? No, so they don't. When I like if I go and I push this to the GitHub, which I won't because it's just a bunch of empty commits, everything that's in my hooks folder, like specifically this commit, this post checkout, and this pre-rebase, they do not get pushed with everything that I pushed. This .git folder is not tracked by Git. This is where all the metadata that makes Git work lives. And so that's why they're in this hook demo folder. And that's why I copied these 3 files into my hooks folder, is because I needed to set that up locally so that they would run for me locally. And so like I recommend, if you're going to do this, have a hooks folder just kind of in the root of the repo. And maybe in your README where you have like you're contributing and you have, here's how to work on this project. Hey, we have a bunch of Git hooks that are really helpful. Here's how to install them. Copy these files into this folder. Boom, you're done. The process of installing them is really straightforward. It was just copying those files, but you have to do that, and otherwise they don't run.
So then you'd exclude those folders. You'd have a .exclude or
No, I
.ignore.
didn't. I would include like my hook demo folder. I'd include that in my repo. I don't have to exclude this I don't have to exclude this .git folder because Git already doesn't track that. Git already knows that that's just metadata about Git.
So you were saying effectively you could put that hooks-demo into your repo itself and then have that as a distributable part of the repo. Is that?
Yeah.
And then
like
there's some mechanism to copy that into your.
Right. Like, so, because you can see illustrating the point again, if I go git status, it tells me I've got 14 and 1, but it's saying nothing to commit. My working tree is clean. I don't have any like unstaged files or anything. Like if I went, if I do that and I do a git status, now it's telling me I have this untracked file, right? Because it's right in the catfax repo, right? If I do the same thing, if I go hi, oops, and I put that in .git/, now when I go git status, my working tree is still clean. Even though when I go and look inside my Git folder, out.txt file is still there because Git doesn't track that folder. Git doesn't track the hooks, doesn't track the info. This is like, you can go and look inside of like, you can go look at the heads and stuff, and you can get into the nitty gritty of like, oh, here are the different branches that I have checked out or that I know about on my local system. And I can go and manipulate them here if I really wanted to. This is all metadata about Git, and it isn't part of the repo that you push and pull and clone and branch and merge and commit to.
Cool.
So yeah, I would have, like, just like I have it set up here where I have this folder. I probably wouldn't name it -demo, but it's got the scripts I'm running. It's got, maybe I could have subfolders in here to make it a little bit more apparent which ones I needed to move into that Git hooks folder. I could even have a script in here that performs the setup for me. Like maybe I have a setup hooks script and it just copies those files into my hooks repo or my hooks folder. You can get as carried away with the hand holding as you want to.
Yeah, I like that.
But again, what you saw when I did a git clone, I had to set that up. So all the files were here for me to do it, but I had to set that up. Okie dokie. So that's the demo. Obviously, we're only scratching the surface, right? That is far from an exhaustive list, but I just wanted to show you. I wanted to run through that list with you first, so you got an idea of the different places, the different events that can trigger these hooks. And I wanted to show you a few different examples of the types of ways I like to use them to interact with PowerShell. And also to really demonstrate they're not a security boundary. Oh, it's hilarious. Okay, let me advance the slide bit. They're not a security boundary. They just let you add productivity, add helpfulness. It's something that you do, that you opt into, that you have to set up for your actual repo. So again, it's not a security boundary, but it will help you. It is a productivity tool. So that's all I've got prepared. Around for another 20 minutes or so to kind of talk about this and other stuff. I'd like to thank you all very much for coming and talking about part of Git that you maybe weren't very comfortable with. Maybe Git in general you're not very comfortable with, and this was definitely off the deep end. But I really appreciate you coming and paying attention to this. Huge thank you to the organizers. This is a great user group. You guys get a ton of awesome speakers and very professionally run organization, and it's always a privilege to come work out with you folks. So thanks once again. I've been Thomas Rayner. This was Git Hooks, and enjoy the rest of your evening.